Hey everybody, John Grimsmo here, and in this video we're talking about Lockbar inserts. How they work, what they are, why people like to use them, and how we're starting to integrate them into our knives. Let's go. All right, so what is a Lockbar insert? All you guys in manufacturing might have no idea what I'm talking about. All you knife guys probably know exactly what I'm talking about. So the knives that we make, they're called frame lock flippers. It's a flipper because it flips, and it's a frame lock because part of the handle, the actual frame, makes the locking action happen. So this bar of titanium that's cut out there, we purposely bend it over, like this one here. So it is bent and held over just a little bit so that when the blade opens up, the lock bar pops into place and falls in the way of the blade closing down. Now because of that, you have a mating surface between like a titanium handle and the stainless steel blade. And there's pluses and minuses to doing it a bunch of different ways. The way that we've been doing it for, you know, the almost 10 years that we've been in business is through a process called carbonizing. So you have your, there we go. So you have your Norseman handle here. The end of that is straight up titanium. Straight titanium is not a good locking surface against the blade. It's sticky, it feels gross. It's just not nice. Like having a sticky lock means you can't disengage it very easily or at all sometimes. You need to like change your hand position, use two hands, put a screwdriver in there. That's not acceptable. So we carbonize it, and here we'll throw over some footage of Eric carbonizing. Basically using a Dremel engraving tool and applying about 45 volts of DC electric current through it, through a rinky-dink anodizing or carbonizing setup that I made a couple years ago, or 9 or 10 years ago. It works, it's just finicky. It's not easy to do it well, and there's always little bits of problems, and we're always going back and forth trying to make it efficient, and it's just not. To get the result that we want, no stick, no slip, perfect lock, doesn't fail, it's tricky. So what we're doing now, especially with the Rask and soon to be with the Norseman, we're milling out this pocket on the handle right there where a lock bar insert will go. All right, so here we have a Rask lock bar insert right off the machine. Very nice, very good finish, chamfers everywhere, nice finishes, made on the kern, looks amazing, works amazing, fits right in the handle. So yeah, later in the video I'll talk about how I make these, but right now I'll continue with the overview. This is made from AEBL stainless steel, very high quality. They call it like a razor blade steel because it makes really good razor blades, but it's just an amazing steel, cuts super easily, and through talking with other knife makers, it seems to be a good solid like first choice for what to make your lock bar insert out of. You can make it out of, you know, anything, but different steels are gonna have different properties. This one seems pretty awesome. This was made, I can tell by how shiny it is, when I started heat treating the blank first, the square, and then I mill it hard. I didn't like doing that because the tool life is kind of garbage that way. So the way we make them now is we machine them soft, and then we mill them soft, and then heat treat each individual piece. And we've gotten very good at that, and the results are perfect. So that's going good. So now, once you have your lock bar insert and you put it in the handle, I made some custom screws that tighten it down. Very similar to our regular screws, just shorter and smaller. So now we have a piece of hardened stainless steel. We're shooting for about 58 Rockwell as your locking surface. So when the blade opens up, now the titanium has a piece of hardened stainless steel in it and keeps the blade open. Say hi to Leif. It's been a long time since you've been in one of our YouTube videos. You are 8 years old now. There's probably some old videos of you as a little toddler, as a little baby. You want to flip this? Tell me if it works. There you go. A little bit hard for small hands to do, but
it's not safe for me to close it.
It's not safe? No?
For me to close it. No.
It's called a guillotine when it chops your fingers off.
This is a giant hand.
Why are you crushing my head, Leif? Stop crushing my head. Stop it.
Man, in reality, it's really small. I just put it really close to the camera so it looks really big.
Crush your own head. I'll crush your head. Like this, right?
Yeah. I'm still bigger.
Okay, do you want to help me with this video?
Yep.
Hey, you just said yes.
Yeah.
Okay.
Yeah. I gotta say then, yeah.
Well, you're going to help me. So you know what this is?
No.
This is a Lockbar insert. That's what we're making? That's what this whole video is about. Okay? This goes in the handle right here.
Okay.
Very precisely. Tolerances are really tight on that. So these Lockbar inserts, you know, we've been making knives for almost 10 years now. You're 8, so since before you were born.
By 2 years.
By 2 years. And a lot of knife makers, a lot of customers and fans have been asking and, you know, wanting Lockbar inserts, and honestly, I was not a fan for the longest time. I kind of thought it was not a fad, but I thought it was not necessary. This knife is sharp, so be careful. There you go, you got it. Yeah, we had a good stable process with a regular carbonized lock face, and it worked. And I had no interest for years and years to do Lockbar inserts. It's a whole nother part you gotta make. It's gotta be heat treated, it's gotta be the right steel, it's gotta be the right geometry. It just seemed like a headache I didn't want to deal with. And then 2 years ago, 2 and a bit, I made this knife. And if you can see right in there, you can see a prototype Lockbar insert. So I tried it. I tried it out. I was like, you know what, let's see what all this is about. If it works, it could change our game. It could make our knives even better, easier to make, more consistent to manufacture. Less of the variances of the carbonizing process. But 2 years later, still haven't put it into production. Oh, that's a nice head scratch. Leif's made new best friends with Fraser and Ryan up in the editing room, doing Minecraft quizzes with each other. Okay. So for 2 years now, I've been carrying this knife with the prototype Lockbar insert. It feels great, it works great, it flips good, has no stick, no lock stick. It does fail because of the geometry. So when we spine whack it against a piece of wood, this particular geometry insert combination, hardness, whatever, will fail. It'll fold, which is bad. Obviously, we don't want that. But in regular use of 2 years of carrying it, it's never failed in regular use. So that's fine. So this spine whacking test that we do is like super abusive and over the top and just not necessary. But it is necessary, but it's not real world application. So through 2020, when I got the Kern and I started putting Rask parts on the Kern, I knew I wanted to redesign the Rask with the Lockbar insert. Look at that sun shining me in the face. Maybe there. I wanted to make the Rask with the Lockbar insert as an improvement, as a consistency improvement, as just new feature, new coolness, and I did. It took a lot of tweaking, a lot of failed attempts, a lot of bad inserts, a lot of heat treat recipes and parts that didn't work, and soft inserts and hard inserts and broken tools, and it's been quite a process. Now I've finally developed a recipe and a tolerance zone that I'm very, very, very happy with. And the parts are just flowing right off the machine like crazy. So I want to apply that same technology to the Norseman, which we are currently doing. So this is the first Norseman I made a couple years ago with Lockbar insert. This is new production. I made all of these parts, almost all these parts on the Kern, including the lock inserts, and it works. It's not perfect. So later in the video, we'll talk about, you know, the hows and the whys of if it doesn't work or not, but it's close. So as of this point, the Norseman has gone through 3 different variations of Lockbar inserts. Let's take apart my first one so we can see what it looks like. This is from 2018, June 2018. So let's take this apart. Man, I carried this thing a lot, and I love it. I went with basically every screw is a different color. It's made of all scrap parts. Okay, interesting. I haven't actually looked at this in quite a long time. So the regular Norseman handle looks like this on the inside. So back then, I wanted to keep it, you know, basically the same, utilizing the exact same screw hole. This circle here is an over travel stop, so that a little disc goes in there. I don't think I have one super close, but a little disc screws in there, and it acts just like this one, so that when you open it all the way, it doesn't over travel. It doesn't move past zero, past flat plane. So that you don't mess with and overbend the spring tension of the knife. It works very well. So using the insert, I can integrate that into the design, which is super cool. So I utilized, this is a threaded hole that we use for fixturing to mount onto the pallets that go on the machines. So I utilized that hole to put the screw in there. That worked pretty well, but there's only one screw holding it down, and I was always kind of iffy about that. Also notice how the D10 ball on the old handle, regular handle, I mean this was made a few months ago, this is regular production now, is the D10 ball, ceramic ball, is pressed into the titanium. Some people press it into the Lockbar insert. I'm not a fan. I think it's too hard of a material, and you lose some tolerance because of that. So if you look closely, I actually have it pressed into the titanium, and the lock insert itself goes around that little post. So I haven't taken this off in a long time. There we go, it's coming. So this is literally made, this was a blade at some point. Like literally I had a scrap blade and I made it out of here. I just clamped up the scrap blade and I just picked a little area where it would fit, and I milled around and I flattened it and I you know, faced it down. This is RWL 34 at 60 Rockwell out of a hard blade. Kind of cool, because that's just what I had at the time. But you can see here, I kept a little bit of a post for the threaded hole and the post for the D10 ball, because we pressed these in using the CNC machine. So I wanted all that to stay the same. And that knife has served me very well. Here's that screw. Very tiny little 1.5 turn thread with a Torx T9 on the end. Love it. So that's version 1. Put all that off to the side as I'm losing screws. Okay. Version 2 happened in the past month or two. So I knew this was coming. I knew I wanted to get parts on the Kern. I knew I wanted to add Lockbar to the Norseman, and how do I make this all work without changing the Norseman too much?
So I got the new blade for the test with the Lockbar insert. This one has a slightly different lock face on the blade, and I'm gonna see if it will fail, like the last one did. Well, that's promising. I think we might have a winner.
So Eric just put together the first prototype of the Kern parts. Flips really good, goes together really good, except what happens?
It fails.
Lock fail. So it fails. I made 2 test blades. This is 0000, and then I have 0015, which is a 1.5 thou change in the lock geometry. That is currently on the Mori right now. It'll be finished in a couple hours with a bunch of other stuff. So once you have that blade, the change should work on that blade to get rid of that slight bit of lock fail. And I do remember the rasks were pretty much the same way.
Yeah.
We made a, you know, on size lock face, and I remember it failed every now and then, like every fourth smack or something.
Same with the Norseman.
Same with the Norseman. And then I changed the rask 1.5 thou. That's why I made a second blade for the Norseman, 1.5 thou. Should be good. So in a couple hours we should be able to figure that out. All right, so that didn't take too long. Angelo got this prototype blade finished. So let's go take it over to Eric. Testing out 0015. I had high hopes, but it does fail. So Eric and I are trying to figure out why it's not fully making sense. So the thing to try now is figure out what needs to change. Unfortunately, both these two blades aren't right, okay? Which sucks, because in order to make this blade, it has to be milled on the current, which is easy. I can be done that in 15 minutes. But then it has to go through heat treat, and then it has to go through lapping, and then it has to have the bevels milled, and that whole process takes a few days. So unfortunately, we're not quite there yet. But progress. I gotta admit, I was kind of disappointed when you texted me earlier and you said, it doesn't work. Yeah. And I was like, I don't want to deal with this right now. I got other stuff to do.
Yeah, because it worked at first. So like I filmed a segment earlier.
Yeah, your first test
worked.
was, woo!
Beat the crap out of it, nothing failed.
Not bad. Promising. This is where the part that it didn't do too well last time, right?
Right. That failed.
And that's why we test it. Ah.
Failure. And then I turn the camera off and mess with it a little bit more, and then it starts to fail, and that was very sad.
Other than that, though, it feels incredible. The pop from the D10 feels very crisp and accurate. There's no stick. The insert feels really good. This one's sharp because it hasn't been tumbled yet, but blade drops like a guillotine. I like it, except for the fail. So we just got to fix that. Have you looked at the taper angle?
No.
So one thing where the lock face contacts the blade right there, like you have your blade and you have your lock insert in this case, they can't be like this and they can't be like that. That would suck. You actually want them tilted a little bit like this so that just the tippy top of the lock insert.
That's the first insert.
Okay, I'll take a look at this closely. It looks like it's doing it. But yeah, you just want the top touching like this, not like this, otherwise it'll stick. So usually we get in there with a flashlight, which I haven't done yet. It might be too much rake, actually.
And not contacting enough?
Yeah, it's contacting just in the top corner. Because that'll fail, it won't be as strong.
Yeah.
That might be part of it. Okay, we'll play with that. So one of the inserts that Eric tried here, they look really good. I'm happy with how they turned out. So you can see the shiny section in the top corner where it's seen some wear and some failure from spine whacking and failing. And I would like to see maybe a little bit bigger contact patch there. So I will change that by changing the insert and creating the insert with this face, I guess this way a little bit more, by like a degree or something. And then I'll make some more inserts. Sky will heat treat them, and then it'll be that going forward. Oh, it still fails. I was hoping it would magically go away.
So yeah, with just the titanium handles and you carbonize, when you spine whack it, it actually like beats down the titanium a little bit, whereas the steel inserts don't really
Much
deform.
harder, yeah.
Yeah, they just kind of get a little bit of a flat spot, but nothing like the handles.
So can you explain why you spine whap?
It's partly to set the lock. so that, you know, if there's any compression in there, then we compress it so it never moves in the future.
You're breaking it in, basically.
Yeah, basically. And then also to make sure it doesn't fail, or, you know, make sure it's sturdy and holds up.
Yeah. Is that something you recommend our customers do?
To spine whack?
Yeah.
I don't recommend it. And if you do it, keep your freaking fingers out of there.
He's a trained professional. Yeah, I mean, there is a specific way to hold it so that you don't drop the knife, for one, or have it fly back at you, but also if it does fail for whatever reason, you don't chop your fingers off.
Yeah, even if the blade is dull, it would hurt so bad.
No, it wouldn't. It would slice right through.
I mean, if it wasn't sharpened yet.
Yeah.
Because I usually do it on an unsharpened knife, so the edge is fairly blunt, but if that came closed on my finger, it would be bad.
Yeah. You'd be missing some finger. Mm-hmm. So we picked out a brand new knife from Eric's Today collection of knives he just finished. Feels good. And I'm using my flashlight and I'm comparing the rake angle, the back angle, whatever you want to call it, with the prototype, and they're similar. They're very similar. Yeah, maybe I'll pull it back a little bit. Like, there's a good chance that titanium, carbonized titanium, and steel lock insert might require a different angle. I know on the Rask I did have to move it from where it used to be back in the day, so maybe I do have to pull it back. We'll see. I just wish I could test and like be back in 10 minutes with a new sample, but it takes days of heat treat and turnaround. But we're getting there. With the Rask Lockbar inserts, I think they're beautiful. I think they're pretty, and I think the dimensions look really good, and the shape looks really good, and the hole spacing, and I think it's a gorgeous piece of metal. And maybe I'm biased because I'm the artist. This one I'm okay with. I think it looks okay, but I really wanted 2 screw holes holding it down. So I wanted to change it from this 2 or 3 year old design. So I came up with this, which I always thought looked hideously ugly. I'm trying to stick with the curves of the handle. I was trying to use 2 screw holes. I was trying to not change the screw positions, and I hated this. But I moved forward with it anyway because I'm running out of time and not happy with it. Notice the 2 screw holes are in the back. I'm going around the original locating hole, and the D10 ball hole goes right there, and this little arc, we'll get into that later. But I just thought it looked ugly. It's like there's too much going on. It's too many angles. I don't like the 2 screws in the back because that could tilt it up. In the front, you want like screws closer to your pivot point or your action point in the front. So I wasn't happy with it. But regardless of me being happy with it, it was a data point. It let us test it, it let us put the knife together, it let us make some blades with some mating features that would work with that, and Eric put the knife together, and I'm gonna post a picture right now. Fraser, make sure we post this, of the picture Eric sent me when he first put this together, and he spine waxed it once, and the insert actually bent away from the handle because the 2 screws are in the back and there's too much meat in the front, and the whole thing just moved out. And I was like, well, that's a result, but it's not a good one. So I was very disappointed with that. Total scrap it, redesign, come up with something new. So after that, I came up with, if I can hold it, this. This guy right here, I'm quite very happy with. I think it's beautiful. I think the lines are nice, the shape is nice. Got some heat treat color from the way we heat treated them. I think this is big and chunky and ugly, and the new guy is much prettier. So I'm very happy with that. And then if I pull this knife apart, that's how it goes in the handle. Works out really, really, really nice. Notice how I actually moved the post, which is something that I did not want to do. I hesitated. So the original fixture location is there. I moved it to back there, which means I have to change my pallets and I have to change the screw location, and I didn't want to do that, but I did it. Because now I get a screw on either side of the post. I get a screw right up by the D10 ball and right up by the lock face. Much more rigid design, much more awesome, and it worked great. And it just looks good. Got nice tolerances, nice and flat. Got the logo in there. It says AEBL on the top. Okay, what I want to do right now is I want to take apart a brand new Rask. I just checked this off. Eric finished it last night. It is going up on the website tomorrow morning. Not like as you're watching this, but for me. So it'll be sold by the time this video goes up. This knife turned out great. So all new Rasks ever since number 330, serial number 330 forward, anything made in 2021, those all have Lockbar inserts. So I'm going to take this apart and show you the finished version, all tumbled and beautiful and nice. Now when I take apart a finished knife, I have to be extra super duper careful because I don't want to scratch the screws. And well, that's pretty much it. Because we tumble the pivot screw to give it a beautiful little finish, and the handle screws are anodized, so I don't want to scratch those either. Okay, here we go. Oh, this is a perfect example, just because of the two-tone anodizing that the guys did. That just looks so cool. So they make it all blue, and then they throw it in the vibratory tumbler, and it scrubs away everything the stones can hit. So the high points. The stones can't get into the engraving, they can't get into these corners. That just looks amazing. Okay. So, yeah. So there's the Lockbar insert installed, stone washed. The little blue titanium screws, obviously we color match the screws with the color of the knife's hardware. That's actually like the only time you're allowed to say the word knives, not knives, because it is the hardware of the knife. Okay, and then to get it out, I'm gonna tap it. There we go, pops out. There's nano oil on the knife, so it kind of suctions its way in there. So the difference between right off the machine, raw, versus after it's been heat treated and then stone washed, it just looks perfect now. Like, it's cool when it's shiny, but this looks so nice and presentable and finished and beautiful. I'm holding really, really good tolerances making these. Very happy with how they're turning out. And then here you can see the difference between a regular handle screw, which is already pretty tiny, and the Lockbar insert screw. Crazy. So, yeah. Also holding really good tolerances on the posts and the locating features and just everything. That's why I got a Kern. In this video, I'm just gonna ramble. I'm just gonna talk about everything Lockbar inserts because I have a lot to say. So now I'm gonna talk about how we've been doing what we're calling the D10 ramp up until now and how we're doing it now forward. We're integrating the D10 ramp into the Lockbar insert, which is a pretty genius idea if I do say so myself. So what am I talking about here? What does D10 ramp mean? I'm trying to keep my face out of the sun here. So the handles, I've already showed you, the handles have this D10 ball that sticks up. As you unlock the knife and you pull the blade down, that ball sticking up hits on the edge of the blade, and then you feel this little bump. The blade is stuck there until it pops past that ball, and then the ball has to move the handle away that extra distance. See if I can show you. So here I'm stuck on the ball, and now I'm up on the ball. Here we go, that's perfect view right there. So this is locked. Maybe if we get some light this way. So this is locked. This is hitting the ball, and this is the ball bumping up. So it's no big deal, but it's just kind of an annoying feature where when you close the knife and it catches on that ball, the blade kind of hangs there, and then you're like, well, now what? And all frame lock knives kind of have this problem. There's a couple ways to fix it or avoid it. This knife drops so fast that the blade actually sometimes bounces at the bottom and doesn't close all the way. Anyway, yeah, so how do you get rid of that D10 bump? What we've been doing until now is engraving. This is a Norseman blade. So while we do the blade serial number engraving, we engrave this little feature as well. So this is where the track that the D10 ball scrapes across. I have a good example right here. That's where the D10 ball is scraping on the blade. Also, side note about that, notice how the top of our ball is flat. We grind the top of that ball flat very much on purpose, because my theory is a round ceramic ball is so sharp and so pokey at the front, at the very tip of it, that it's like dragging your fingernail across a surface that you think is smooth, but you feel every little bump and every little imperfection. Whereas a flat ball is more going like this. So we've found a much smoother knife by having a perfectly flattened ball that is exactly parallel with the blade surface, so that it slides and makes the blade drop faster. So you got your two blades here. This one shows the D10 path. This one has a little ramp that we engrave in there that lets the ball kind of ramp up there. And it works and it's fine, but I've never been blown away, like amazingly happy with it. So for years now, 3 years probably, I've been trying to crunch, and I've had this idea in my head for over 2 years on how to integrate that into the Lockbar insert. And now with the Kern, with all the tools that we have, with the quality we can do, with the accuracy we can hit, and integrating the Lockbar inserts into the Rask, I'm able to do that. So check this out. What we're doing here, we'll do it on the finished lock insert. So here you can see that little nub right there. That's what I'm calling it, the D10 nub. That little nub, and then we have, where's my big ugly inserts? These ones, the Norseman ones, have a gigantic nub. That's just how it works. So what does that do? So here's how the Lockbar works. This is actually a pretty good angle for you, if I can keep it in focus. So when I move it out of the way, then the blade is able to close. And you can see, imagine if that nub was not there. You have this travel distance before you hit the ball, and then you have to bump up onto the ball. So I was like, why don't we just extend the locking surface, create that nub, so the second you unlock the knife, now you're on top of the nub. And if that nub is almost perfectly level with the ball, then then you're already there. Then you have none of that dead zone waiting for the ball to hit. So my D10 nub on our Lockbar inserts basically eliminates that entire problem, and it works so good. So fantastically good. And the trick is you need a corresponding arc in the blade for that nub to land. So that's why each of these has kind of a mating nub, so that when the knife is locked in place, that nub has somewhere to sit, somewhere out of the way. There we go. So the rasp blade, it's got a very small nub, and we have a arc right there. That the end point of that arc on this side, hang on, buddy, is where the D10 ball catches. Very important, very critical feature. The rest of it is just clearance. You got some small fingers entering the frame here. Hopefully that sort of starts to explain the D10 nub and the Lockbar insert and how they all work and how they go together while Leif's trying to operate the kern. You gonna do it? All right. Let's go a little bit faster. There you go. Don't crash it. So yeah, while Leif's doing that, suffice it to say, I am very happy with how the Lockbar inserts are turning out. It's been an incredible amount of work, and I love it. Whoa, tip it out. Look at this, it's kind of cool actually. Coolant?
I don't want to get that coolant on the power.
Watch out for the tool there, don't crash it at the top. Yep. Careful, careful. That's as far as it goes, okay. Leif is playing with my office chair with the roller skate wheels on it, rollerblade. Okay, let's move to the manufacturing section of how we make this. On the kern, I'm using my small 72mm pallets to make the Lockbar inserts. I've messed up a couple of them. This morning I made a mistake and I broke the whole pallet, so I had to make a new one today. So that's what I just finished right now. So here we have a rasp pallet, nicely faced on the top. I get to hold 4 inserts on it. Threaded holes around the outside for top clamps. We'll get to that in a minute. And this is, the outline, the shape of the fixture of the insert. And there are threaded holes and clearance holes to do hold down clamps from the top. So this is my threading tool that I thread the M6 holes on the outside. Then I have a smaller tool for the inside. And I've made so many of these and so many other pallets that these tools were actually chipping and worn out just a little bit. Like I was at the end of their tool life, no big deal. But my threads were coming out under spec, under size, so I'm running them again. So what I've done, let's do it now, I'll cancel that. What's cool about hide-and-hide control is you can scroll down to the exact line that you want. My tool 104, single point thread mill, to do thread mill 440, perfect. Yes, I have inch 440 threads and metric M6 threads on there, don't ask. So I'm halfway through the code, right? There's my progress bar. Halfway through, I can do block scan. It's gonna read all the code up to here once I hit cycle start. It's literally reading line by line, figuring out what it has to do, where it has to move. It has to do all of these. M19 is spindle orient, M1 is to pause, blah, blah, blah. So I hit cycle start and it's turning, in its brain, it's turning on the coolant, off the coolant, on the spindle, off the spindle. And it's doing a tool change right now because before that tool, there's another tool. So it's calling my thread milling tool, my smaller one. There we go, tool change. That is the drill before the thread mill that I want. And now it's asking, I have to move to a Z position, X, Y, B, and C. So I hit cycle start again, and it moves to a safe position. It oriented that because Leif was playing with it. And now, resume the program at its current position. Yes, I can. I'm confident that this is going to work. So it's going to put in the right thread mill that I need. All I'm doing right now is recutting those 440 threads. And this is a new tool, so it's touching off the tool length. And I'll do a whole nother video about how I'm doing that because it's pretty epic. So this is the laser tool setter. So I replaced the tool. That's why it's trying to touch it off right now. It is touching it off. And you can see the laser beam. Once it goes to the other side, we'll see it better. There we go. The laser beam is accurately measuring the diameter and length of that tool. Okay, it's touched it off. Yeah. There's a whole reason why I'm doing a tool change right now, but give it a second. Okay, now it's going to call that tool back. And now it's going to do some thread milling. There we go. I'm going to turn the coolant off so you guys can see. It's just recutting the thread, so I'm not too worried about the coolant. Cool, eh? So that's what single point thread milling looks like. It's doing about 5 or 6 passes, I think, per hole. Maybe a little bit more, yeah. Look at that. Starts at the bottom and it spirals its way up. Okay. Yeah, the one I just ruined this morning was this one. I ran the wrong code on it. You can see I ran through the middle of some of the sections. But this is the pallet. Notice I've created my own dovetail on the bottom with a locating feature. And you go over here to the back of the pallet changer. These are all my pallet blanks, where this locating feature will fit right in there. And then my dovetail grippers tighten down and hold the thing down. So I will have lots of these once I get this thing all loaded up. Not just for Lockbar inserts, but for all kinds of other parts that I have to make. So on that note, so that's the Rask one. There's another bad Rask one that I've already screwed up. Here's a blank ready for more. And then my Norseman one is here. This is how I'm making the Norseman Lockbar inserts. Same exact thing. Here you can see my top clamps. Here, I'm gonna load that up and I'll show you in a second. Okay, so when I first got the Kern and I knew I wanted to make Lockbar inserts on there, I thought I wanted a fixture that would allow me to rotate the part and hit it from both sides. So I came up with this. Same dovetail base we just talked about. This is a window fixture that my buddy Saunders kind of got me into. It's got a top clamp there. Nice little swoopy design. Lets me put a piece of blank in there, tighten it down, and now I can machine from this side, I can flip, I can machine from this side, I can flip back and forth and back and forth. And I did it and it worked well-ish. But I noticed difference in thickness between the 4 inserts. Okay, just making sure the machine did stop when I wanted it to. I noticed the thickness difference between the 4 inserts that I was making, and I wasn't super happy with it, and it vibrated a little bit, and blah, blah, blah. So I wanted something else. That's why I'm now doing the flat lay fixtures, which seem to be working out much better. Yeah, so I put a lot of effort and thought into this, and then I ended up scrapping the idea. That's progress. That's just how it works. The other thing we did is I thought if we heat treat the blank, the actual piece of material, it'll be much easier to heat treat, which it is, but much harder to machine. And like I said before, tool life just goes down the toilet when you're machining such hard stuff, and I just didn't like it. So I wanted to try machining them soft. So I did 2 things. Created the flat lay, started machining them soft, and at the same time we got our Okamoto surface grinder. So what Angelo has been doing is surface grinding one side for me, and leaving the other side blank. I don't need both sides surface ground. I just want one side done. So he's surface grinding one side. Now we have one perfectly flat plane that goes onto the insert pallet, which is faced on the kern, and it's nearly perfectly flat. So now you have two flat pieces going together, no warpage, no nothing. And then I machine the top of the insert for thickness, and it's golden. It works really super duper well. Also, Angelo had the fantastic idea, he's been actually pushing this for a while in various uses, to use these grippers. This is a part I get from McMaster Car. Look at this thing. There we go. Look at this. This is a hardened steel and then a black oxide coated gripper pad. They make them in all different sizes. This is kind of the smallest one. It's threaded with an 832 thread on the back, or 824, whatever, 8 something. And it's grippy. So I integrated these into the fixture, one there and one here under this clamp, so that as the workpiece slides in, then this clamp and this clamp will grip onto it. And it leaves the most beautiful little indent in there, and now you're certain that the material is not going to shift. And if it does shift, you'll see a scoring on the feet. So it works great, and they're cheap. They're like $7 each or something. Totally worth it. Totally doing that. So I engraved these two little arrows that way, telling me this is the clamp to take off, and then my material goes shiny side down, because that's the side we're not machining. And then I tighten these down, and then I put the fourth one on there, put it right on the top, tighten them all down. I tighten them down with the drill, and then I torque it with our Sandvik torque wrench. This thing works great. Tighten it down, click, click, and yeah, this works awesome. Then I'm left with these. This is what happens after machining a Lockbar insert. So you can see on this side, the surface ground side, and the gripper marks. Pop, 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 and down here too. It's beautiful. Here's the ones I screwed up this morning. Whoops, we ran the wrong program. But this shows actually quite nicely. So here's a RASC insert that's made, just needs to be profiled out. And then I made these little top clamps. So I machined these little top clamps because the theory is you make the insert, and then I drop in a screw and I tighten it down into the threaded hole in the fixture. And then I can profile. Now each individual insert is held down perfectly. And I can profile all the way around it, all the way through, and back chamfer it and make it perfect. And that works great. Except these screws were actually putting dents into my part. Not cool. So I machined these little fake Lockbar inserts as a cover so that these can get dented and the insert doesn't. And it works great. So, yeah. Whew. That was a lot to talk about. I've been sitting on this for like a year, picking away at it, haven't filmed it, haven't talked about it, so I'm trying to just tell you guys everything. I mean, yeah, that's how we make it. They're going great. Norseman, RASC, Kern's doing good. Welcome back. It has been an entire week since I last filmed about this project. We have put the new blade through heat treat and lapping and bevel milling and assembly, and Eric put it together this morning, brought it over. I've been playing with it for a little bit. It is better, but it doesn't feel quite as good as the last ones, but it doesn't fail, so that is a huge improvement there. So I'm trying to find that balance between where is the sweet spot between the angle of the lock face and the rake angle between the insert and the blade tang, and just trying to figure it out. So Right now, the way it feels, it doesn't fail when you go like this against a piece of wood. That's fantastic. That's a huge hook, good in the right direction. But it feels a little spongy. Like when you unlock it, it's not sticky. Like some knives have lock stick, where you like need two hands to do that. It's not sticky, but it's close. It's like on its way to being sticky. It's like borderline acceptable. Of all the knives we check every single day, you know, Eric finishes every knife and I check every knife before they go out. I've certainly sent out knives like this that have this amount of stickiness to them. It's minuscule, but it's not perfect yet. We can do better. But how many weeks do I want to, you know, make one blade, send it through the whole process, assemble it, etc. So I think I'm going to pull back the change that I made by like 30%, and then I think that should be amazing. So I think I'm going to make maybe at least 4 blades with an actual serial number on it and get them through. And if they work great, great. If not, then step 2. I'm pretty happy with it. Feels amazing. I've got my Leica microscope here, and I'm just kind of looking at, you know, trying to use the microscope and the light to really see everything. So I've been playing with this knife for a while now. There we are. And testing out, I have 3 different blades with all different lock geometries. I have 2 different kinds of Lockbar inserts, each with a different rake angle, the mating angle between the blade and the lock insert. One is 0.5 degrees back, which gives me about 3/1000ths at the bottom, like sweep backwards. Trying to figure out what's the best combination, which one works best. So I went back to the blade that is furthest from good. This is the blade that failed the other day with Eric, and I'll show you what happens now with the new insert. Basically immediate fail. So that's okay, that's progress. Yeah, that's not good. But that is good because it's a result, and it proves that this blade is too far the other way, so the lock geometry fails. And I don't like that. But the blade that I made, that we finished up today, is on the extreme opposite end, and that sticks a little bit. And the blade right in the middle also fails a little bit. So I've got, it's a much tighter window than I expected, actually, than I thought. But I think I know what I need to do to make some more blades. And I think we're gonna make a small batch with actual serial numbers, and I think it's gonna work. I think. It's a big deal because this is going to be the new production for us, the new way that we do our Norseman. Half of it on the Kern, half of it on the Mori. And that's a big deal. I want to get it right, I want to get it perfect. This machine is super duper consistent, so once I have the right method, it'll repeat it very, very, very well, but it needs to be the right method because I don't want to keep repeating bad method. So yeah, it's really interesting feeling the differences between these 3 knives, these 3 blades, ever so slight. You know, I've felt almost 5,000 of our knives now. I'm getting a feeling for it, and I can tell a noticeable difference between the 3, and it's cool. I'm just gonna play with it, think about it for a second. All right, so I put back in, of the 3 blades, I'm calling this, yeah, plus 1.5 thou, 0, minus 1.5 thou. And the minus 1.5 thou, these are arbitrary numbers, they don't mean anything to you guys, but they're how I've tapered and angled the lock face on the blade. So plus 1.5, 0, minus 1.5. And the minus 1.5 feels great. It just feels a little spongy. Okay, when the lock engages onto the blade, that's a pretty good shot right there. Obviously it gets in the way of the blade. There's a little bit of a taper, so that keeps the blade open. It just feels a little bit spongy. Like you disengage it, it's got a little, it's not grab, but it's just a little like, meh. And some of the knives we put together, it just feels right. Just feels amazing. I want that on everything. You know, we pride ourselves in our consistency, but here in the shop, no customers around, we work very hard to make sure that consistency happens. And on a micro level, it doesn't always happen. We're always chasing something. We're trying to make it slightly better, slightly more consistent, slightly more accurate, slightly tighter, flatter, shinier, sharper, whatever. And we're perfectionists, and we're never truly happy with something, at least not for a long time. You know, you might be like, yeah, I nailed it. And then a week later, you're like, I can do a little bit better. All right, so we have a little bit more testing to do, but we're basically done. We just got to tweak a few more things. We'll do another update once they're deep into production and everything's going great. So Eric's excited to get these in production. So let's do that. All right, see you guys.